Now we are going to deal with a problem based on Bayes' theorem. This problem is, at a certain university, 4% of men are over 6 feet tall. 4% of men are over 6 feet tall. Okay, and 1% of women are over 6 feet tall. 1% of women are 1% of 6 feet tall. Okay, is, let's say, 6 feet tall, and the total student population is divided in the ratio 3:2 in favor of women. So 3:2 total population is divided in favor of women. Then if a student is selected at random from amongst all those over 6 feet tall, what is the probability that a student is a woman? Okay, so probability that a student selected is a woman, given that selected students are over 6 feet tall. Okay, you have to calculate this. Now we will approach this with Bayes' theorem. So we'll just first start with M. Let's say M is denoted for student is male. Okay, or man. Then F for student is female. Okay, then you have you can say T as for 6 feet tall. Okay, for student is over 6 feet tall. Okay, and you know that P of M is what? 2/5. Okay, 4% of men are over 6 feet tall, so it will be 2/5. P of F is what? 3/5, because total population is the total probability of M and F will be 1. So from this thing you have this relation, total populations. Okay, 3:2, that means total is 5 and 3/5 is for female, 2/5 is for male. Okay, 3/3 plus 2, 2/3 plus 2. Okay, this is done like this. Now we'll move on. So the probability of 6 feet tall given female is 1%, that is 1/100, and similarly probability of T given male is 4/100. Okay, now we have to calculate probability of F, that it is the student selected is a woman, that is student is female, that is F, given 6 feet tall, that is T. Okay, this is required probability, which can be written as, from the Bayes theorem, which can be written as P of T given F, P of F upon P of summation of P of F, that will be P of T given F into P of F plus P of T given M, P of M. This is the summation, this is equivalent to P of T. Okay, now this will be equal to 1/100 into 3/5 upon 1/100 into 3/5 plus this will be 4/100 into 2/5. This will give you 3/11. Okay, so this is the Bayes theorem. This is the classical Bayes theorem. Now we are going to solve this problem with the help of a shortcut. That's called a tree diagram. Okay, so we'll move on. Let's make a tree diagram for this. Okay, so for when you are going to make a tree diagram, you are going to start with a box. Okay, now we are given that there are men and women, okay, in a population. The probability that it is a male and it is a female is given to you. It is 2/5 and 3/5. That 3:2 will make this thing. Okay, now if it is a male and it is over 6 feet or under 6 feet, there are two conditions. Similarly for here, it may be over 6 feet and under 6 feet. Okay. Now we are not dealing with under 6 feet, so we'll ignore these cases. We'll not write the probability on the arrow marked. But over 6 feet, we have 4%. That is 4 by 100. For this female, we have 1%, 1 by 100. Now, what we are going to do? This is our tree diagram. Okay, we have made a tree. These are our branches. These are M and F are our nodes, and these are our branches. Okay. As we are not dealing with under 6 feet, so we'll just ignore this case. Now, the probability of a female given that she is over 6 feet will be over 6 feet. Okay, let me use another pen. Over 6 feet, female. So we are talking about this branch. Probability of that is what? 1 by 100 into 3 by 5. Fine, because this branch into this branch, okay, we multiply the probabilities in a tree diagram because we are going from this for this whole branch, okay. So we are going from the down to the start, and we are just multiplying the probabilities. Now when you have done this, you will see the total cases. Total cases are what? Total cases are over 6 feet, this one case and this one case. So you will write the total probability in this case, okay. So that will be over 6 feet, this branch, that is 4 by 100 into 2 by 5 plus 3 by 5, this branch again, because this is included in total probability. This is just a case, this is the total probability I am writing. So 3 by 5 into 1 by 100. So that's the same as 3 by 11, okay. 3 by 11. So this is the same method, just it's easier to do and it's faster. So you can use this one in JEE exams because every base theorem problem can be solved by this, okay.